Hello, this is Derek Dean, the Vice President of the SCADA and ADMS departments at ETAP, and I want to give you a big thank you for joining my presentation, which is on the eProtect product in the ETAP suite of solutions. First, I'd like to discuss very quickly the agenda. So first, I will discuss what is eProtect. Then, I'd like to go through some of the inspiration for the eProtect product, and then I'll go through the solution details and then give you a demonstration of the software in action. So first, what is eProtect? eProtect is a centralized protection and asset management solution. This means that is an enterprise relay management solution where you can download, parse, update, and manage relay settings directly from the relays. You can validate relay settings in ETAP using star and star Z. So if you're familiar with the protection coordination studies that we support already, it integrates seamlessly with that tool. There's an integrated workflow management solution, and you can validate your electrical model and settings after events using disturbance records. So what was missing in the industry that we felt needed to be resolved? So first, the as designed oftentimes did not match the as found. So someone would go in the field and change the settings on the relays for potentially good reason, but that never makes its way back to the engineer who is doing the protection coordination studies. This can lead to major issues if you build new protection schemes assuming that what you have already is accurate in your model. A lack of formal repository of settings. So oftentimes the settings are just whatever happened to be on the relays, and there's no actual formal repository that ensures that you know what the settings are at any given time. Lack of change control and change auditing. So as new people join the company or just through time, there's no way of ensuring that certain users who made changes, that you know who made those changes. Lack of validation of settings and electrical model after events. So after an event, you want to be able to validate that what actually happened in the field matches with what you're expecting to happen when you look at your electrical model. So you can validate that electrical model against actual events in the field. Regulatory requirements, so there are some NERC requirements that are pushing for much higher level of validation of tracking of your relay settings. And a big one at the bottom here is many different software packages are required to manage. So each different vendor has their own software to connect to the relays. And so now you have, rather than just one repository of settings, you can have 5, 10 different repositories of settings because you're using 5, 10 different software packages that have the history and all of the settings for your relay. So it can be cumbersome. You don't have everything in one centralized location. The eProtect solution. You may have seen this slide before if you've seen any other eProtect presentations, but I think it's very informative. The key piece here is you have the protection relays in the upper left-hand corner, which is providing the as found relay settings to eProtect. And you can bring those as found relay settings from eProtect to the design and analysis workstation. So for instance, you can bring those settings in to ETAP, the ETAP client, so you can run star Z protection coordination studies with the actual settings from the devices in the field. From this, you can find your as optimized and as designed settings based off of your protection studies, and you can send those settings back to the protection relays. Additionally, fault waveforms can be downloaded from the protection relays and brought into the design and analysis workstations for calculations of your advanced fault analysis. So here we can download a ComTrade file, do an analysis of that ComTrade file, find the field sequence of operations and the as calculated sequence of operations in ETAP, and validate that your protection scheme actually is working the way it's expected to be. And then on the bottom right hand corner we have the eProtect web clients, which gives you very good visualizations into all of the aspects of eProtect. And I'm going to go through all this in a demonstration. So eProtect, like many of our solutions, it leverages a suite of different products. So on the left, we have the Relay Explorer. So this is a web user interface where you can see all of the relays in your system, be able to import your settings and find differences between settings, etc. As I mentioned before, STAR and STAR-Z can be used for your protection coordination studies. Ensure that you're actually protecting the equipment and you don't have unnecessary trips of equipment, and you don't have, but you are properly protecting everything. SOM, or switch order management, is a work order management solution where you can create a work order request and go through step by step the process of extracting, validating, and updating the relay settings. And then the last one here is ETAP AFAS, the Advanced Fault Analysis Software, where you can actually look at an actual event and validate that the protection that was executed because of this event matches what is the protection in the ETAP solution. So now I'm just going to go into a little bit more detail of some of the different features of these products. So for the Relay Explorer, we have a library of settings processors to collect all settings into one repository. What's really nice is that many of the major vendors, they have product lines that follow the exact same format. So once we support one vendor product line, every single device from that product line is supported. So we do have a robust library of settings processors right now. It supports relay history management and compare settings through time. So you can look at who's done what and what the settings were in the past, what the settings are now, and you can compare line by line, see exactly what's changed through time. Say, what were my settings for this relay 1 year ago, 6 years ago, yesterday? And you can compare that on the web user interface. You can categorize and add attributes to relays for grouping and sorting. So this is more of an asset management functionality where you can bring new parameters in and categorize your relay assets based off of those new parameters. And we track all changes to the settings. Anytime a change is made, any sort of user interaction is made, we track all of that. There is also a REST API as part of this, so third-party integration can be done where you can download, using the REST API, you can download the settings that eProtect actually calculated and parsed out. For the AFAS solution, we automatically download disturbance records. We have waveform visualizations, alarming and notifications. So you get an email, let's say if there's a fault on a line and we've downloaded a disturbance record or a ComTrade file. And then we calculate critical information using the digital twin plus the disturbance records. So we basically run back that the fault currents, the fault voltages, all the other critical information associated with the fault, bring that in to the ETAP model and determine where the fault is, what type of fault it is, what was the correct protection operations, and what actually happened in the field. And you can make a lot of very important decisions based off of that information. So here we can see for the AFAS calculations, your field sequence of operations, relay information, fault severity analysis, fault location, the ETAP sequence of operations, and I'll go through this in the live demo. Now I'd like to start demonstration. So here I have my ETAP model, but more importantly, I'm going to jump into my switch order management tool. So this is ETAP SOM, or switch order management, and I'm going to put in a new request. And I'm going to put it on behalf of ETAP RT, and this will be a maintenance request. I can put in a component name, and actually I will put in r_main ld_1. So this is a relay on my main load. You can actually use the component picker to find amongst the components in the ETAP model, but I already have the name here, so I'll just use that. You can propose a schedule, so I want to do this on Tuesday, and I suspect it'll take about 2 hours, but you can define how long. Relay settings management, so validate the relay settings for associated relay. There's a number of other parameters, but for the sake of brevity, I'm just going to move forward and generate my request. And now I should see my new request here. So now by generating this request, and anyone can generate this request, it becomes available to the engineer who's in charge of this area of responsibility. So this could be your tech in the field, could get triggered to go and extract the settings, or it could go to your engineer. It really just depends on how you set up your organization. But here, after I've selected this this file here, or this record, you can see all the details in the info section. And I can go and review. I can assign individuals to this action. And then I can send for approval without a switching sequence. We don't need to actually open up any breakers or anything to be able to extract the settings, so I can approve that, and I'm going to approve for execution. So this is part of our overall switch order management tool. So there are some extra steps, but you can have different individuals process and approve of different steps. So here when I go to the switch plan execution, you can see there's 4 steps. Extract relay settings, import relay settings into eProtect, validate relay settings in ETAP, and then update your relay settings. So and this is completely configurable on a per project basis, so you can define how you want your steps to be perceived, but these are the defaults. So the first step is to extract the relay settings. So in this case, I've done this already, but you would use the OEM software to download the settings from the relay. I'm going to say I've already done that and hit proceed. Next, you want to import your relay settings to eProtect. So I'm going into my Relay Explorer in eProtect. I'm going to find that relay, and I happen to know it's in my Angel substation, and it's right here. Select Import Settings. Select the file. So I've already predefined the file. So this came from the accelerator software. I can say update for demo, and I have to define that as a Schweitzer relay. Hit OK. And I am parsing that file right now. You can see that now I've actually brought in all those settings. Here are my as found settings for this relay. And I can go through and see that there's almost 6,000 items that we've brought in. So there's many different settings here, and that can be used for, some can be used for ETAP analysis, and some is just used for record keeping. So next I'll go to my versions, and I can say, well, show me a diff report between with my settings right now and my settings from a week ago, and run the comparison. And here we can see a line-by-line diff, so you can see that the CT ratios were changed, the PT ratio was changed, the previous value and the new value can all be seen here. I'm going to cancel that, and I can go to my switch order, and I can say import relay settings to eProtect. That's done, so I want to proceed. Validate relay settings in ETAP. So right now these settings have been brought into eProtect, into the Relay Explorer, but now what I want to do is I want to send those to ETAP. So I can do analysis. So here, send to ETAP. Here you can see the difference, my base revision in ETAP, my eProtect revision in ETAP, and then my new values. And so the only things that are changing here are my pickup and time dial for my overcurrent relay protection, and it's changing to 3 and 1 here. So I'm going to send to ETAP, hit OK. So now with the settings uploaded to the ETAP model, I can go into ETAP and navigate to my component. So if you're not familiar with the concept of revisions, we use the eProtect revision, which is our as found settings, and our base revision, which is our as designed settings. So then we can always keep a track of our as designed versus our as found settings. So here I'm going to double click this relay and look at my values. So my pickup is 3, my time dial is 1, as we saw in the file, and I'm going to run a quick star auto evaluation. And we can see very quickly that there are some violations. If I go to my transformer section, I'm going to expand my curves, and you can see here that I have a couple of violations which I can very easily resolve by moving, adjusting some of my settings here. So now everything looks correct. If I look on my load side, on my cable side, everything is properly coordinated and protected. Now, if I go back to ETAP in the component, you can see I've changed my settings. And if I go to my base revision and merge those settings from my eProtect revision to my base revision, as I do here, this will have the effect of creating a new version in eProtect Relay Explorer here. So you can see here I have my as designed settings in the Relay Explorer. The benefit here is now you can either send it to the device or export this out to the vendor file. So going back to my workflow here, I can proceed saying I've validated my relay settings, and the last step being update relay settings to the actual device. And I can say I proceed there, assuming that I were to export my settings here. Additionally, as part of this solution is the AFAS, Advanced Fault Analysis Software. So I'm just going to show you one fault that has been processed. So there's one fault here, and you can add your own custom labels just to track each fault. But every time there is a fault that has Comtrade files, we bring in those Comtrade files, group them together, and then create an event. And here I can look at the field sequence of operations. This is all of the digital inputs from the relay Comtrade file. So here you can see from the field, this is what happened. The fault location. So here we have multiple different algorithms to calculate the same thing, the fault location and the fault type. So you can see that the component is this L1 line, there's an AG fault type, and then it's around 50% line. So you can see different algorithms have different accuracies and are more optimized for certain things. We can look at the relay data, see the pre during fault and post-fault current and voltage here. You can see that it's broken up into a number of different segments, and I'll go through that in a second. You can see here in the fault severity section, we can show that this is a permanent fault. This is actually a reclose scenario. So here's my fault current and fault voltage, my fault resistance, but there's actually two faults here because it trips and then it recloses. And then here's my ETAP sequence of operations, where you can see the step-by-step what actually ETAP would perform if there was this fault in the system. So for instance, here you have two relay trips for these two devices, and then there's interlock trips for these other devices here. So there's actually an entire bus that gets tripped as a result of this fault. And so you can compare that against your field sequence of operations. And additionally, we do have an application, our waveform viewer application, to be able to visualize these Comtrade files as well. So here I will bring up one of the Comtrade files, and you can see here how there are two faults. The fault first happens at this point here, and then the protection trips, and then here you can see as I go further to the right, here we close the relay again, and or the circuit breaker recloser, and you can see that it again has a fault and then trips off. So this is a permanent fault. You can see the digital inputs here, and you can actually create calculated tags, and there's a lot of other information here. So I can bring in my RMS information, my phasor information, my frequency harmonics. All of this is available through our digital signal processing to expand on the information that you're provided here. Okay, so now I am going to go through some questions. First of all, I want to thank everyone. Question 1, what relay manufacturers are supported? So this is a question that we get all the time, and it's something that changes every day. Because we are constantly upgrading this library of relays, and once we get one vendor supported, it's very trivial to bring in additional product lines because they typically use the same settings formatting. So we do support most ABB, GE, Micom, Schweitzer, Siemens, Rayroll. There's a bunch of other smaller relay manufacturers that I'm not thinking of off the top of my head. But if you do have any questions, you can always send an email to me, and I can provide some additional information. But as I mentioned, on a per project basis, if there are some specific relays that you're interested in, we can bring those in relatively seamlessly. Another question is, can this solution be integrated with ETAP real-time? Yes, that's actually a very good point. One thing I forgot to show, let me bring this up, is you can actually, as part of your eProtect user interface, you can bring in dashboards. So here is a dashboard that I like to show a lot. Here's my panel, and each of these buttons here are dynamic, and I can show real-time data for each relay. So here's relay 1, which has my measurements here, and if I go to relay 2, I have my different measurements for relay 2. So here we can actually create one template and then associate those templates with the actual relays and bring that information in. Now, whether you just want to show the information for each relay, or if you have a PSMS solution or an ADMS or an OMS, whatever your solution is, this fits in very nicely with that solution. Because you're already talking to the relays, you already have the infrastructure of ETAP real time, so that's a very good point. Does this require that eProtect be on the same network as the relay network? This is a very good point too, because no, it's not required that the servers, that the web server or any of the infrastructure be on the same network as the relays. You only need to have the OEM software, so Accelerator, Dixie, etc., on a machine that's able to access the relays during the time of relay setting extraction and upload. So it doesn't even have to be, it could be a laptop that only has the OEM software installed. You connect to the network, extract the settings, and then you connect into the corporate network or the less secured network, and you can import those into eProtect and do your validation studies. So this is very nice because you don't have to worry about having very strict cybersecurity requirements that you have on your operations environment, where your relays are actually located, where you can have open a breaker accidentally or anything like that. Can one eProtect be used for multiple facilities or multiple models? Yes. So here, if I go into my Relay Explorer, you can see here I actually only have one project, which is example star Z, but in this architecture here, I can have as many projects as my system will allow. So if you're licensed for. So we use NetPM, and if you have more projects in this NetPM architecture, they're all going to be available here in eProtect as well. So you can, let's say you have your one large company, but you have 5 different facilities. You can manage each different facility separately as a separate entity here, as a separate model. Okay, that is all that I have time for today. Let me just share my screen here one more time. So if you do have any questions or any feedback, I would love to hear it. Again, my name is Derek Dean, and you can reach me at derek.dean@etap.com. Thank you very much.